Functional Notation Part 1. We're going to be looking at the definition of a function. So what is a function? Imagine we had a box, kind of like a vending machine. It has a set of instructions which requires an input to the machine, and it takes that input. Using the set of instructions, it then produces an output. Imagine we had a money doubling machine. As the input, we would put £1. Then it would take that money, and the instructions would be to double this pound, and we would get output of £2. This is effectively what a function is doing. Mathematically, we can give the input x and we have the output as y, because by convention this is what we use on the xy grid, the Cartesian plane. So say we have our input and we have input 1 and input 2, x1, x2, and then 4 we're going to have the output y1 and y2. And we want to double each input to produce each output. And we have the function y equals 2x. And this function is taking each input, doubling it, and producing the output. Say the input is going to be 1 and 2. The function is then going to take each of these, double them, and so the output is going to be 2 and 4. And we can show this on the Cartesian grid like this. This is the function y equals 2x, because x1 at 1 is going to produce y1 of 2, and x2 of 2 is going to produce y2 of 4. Another function could be x squared. Say the inputs are going to be -5 and 2, the outputs are therefore going to be 25 and 4. And this is what the function y equals x squared looks like. So for our functions, we have a set of inputs and we have a set of outputs. We call the inputs the domain and we call the outputs the range. We'd also call the inputs the independent variables, and because the outputs are dependent on the inputs, we call them the dependent variables. And a function has a single output for any input. However, we might get something that looks like this, where we have one input with 2 outputs or more outputs. This is not a function. A function may have 2 inputs with the same output. This is acceptable. This is still a function. So to recap that, a function must have only one output for each input, like this. Or a function may have one output for 2 or more inputs, such as here. A function must not have an input with more than one output. This is not a function, but it is called a relationship. So here's a function. We can see here that each input, each x value, has only one corresponding y value. For example, here's the output y, and we can see that it has only one input, or one input has only one output. This is a function. A different function might have the form of having more than one input to the same output. So here's one output with multiple inputs. This is okay, this is a function. This, however, is a relationship, because we have more than one output for any one input. So here is an input at x equals 9, and it has 2 solutions. So this is not a function.